Hello, algebra students. Mr. Lawrence here, and I had a request from Jackie Pearson to make a video about 9.3 and 9.6, which can be summed up as the quadratic formula and graphing. It's going to look like I'm going to start a little bit backwards. I'm going to start with the quadratic formula, and then we'll talk about the graphing part of it. So, excuse me. All right, first thing is I have a quadratic equation here, and I'm going to need to solve it. And remember, the solutions to the quadratic equation, also known as roots, are the places where the parabola crosses the x-axis. So I'm going to go find A, B, C. Easy as one, -6, 7. Right? Okay, and now I'm going to go to the quadratic formula. And the quadratic formula is going to be x equals negative of b. Oh, look at that. There's a 6 there. Why is there a 6? Did you catch that? Because b was negative, right? So the negative of b is positive 6 plus or minus the square root, okay, b squared. Notice I put it in parentheses. So many of you are ignoring it. You do the parentheses on the minus 4ac part, but you don't do it on the b squared part, and it's causing you to get the wrong answer. Minus 4ac. Oops, I know what a and c are. Why am I not filling them in? Sorry about that. Okay. A and c all over 2a. All right, so we get x equals 6 plus or minus the square root of 36 minus 28, and that'll be over 2. And so now I'm going to have x equals 6 plus or minus the square root of 8 over 2. I can go to a calculator at this point, but I'm going to simplify it just in case they want it in rad form. And you remember how to simplify rad 8? We've got to find a perfect square that is a factor of 8, and we would like to get the largest perfect square possible. Can't I think about the square root of 8 as the square root of 4 times the square root of 2? And the square root of 4 is 2, so square root of 8 simplified is 2 rad 2. So my two answers in exact form are 6 plus or minus 2 rad 2 over 2, but that can be simplified because the 6 can divide evenly, the 2 can divide evenly into 6, but it can also divide evenly into this 2 here, right? Not this one, because that's not 2, that's the square root of 2. All right, so I'm going to divide by 2, and I'm going to get 3 plus or minus the square root of 2. Now that doesn't really help me graph because I don't know where to do the square root, 3 plus the square root of 2 and 3 minus the square root of 2. So I'm going to go to my calculator at this point, and I'm going to do 3 plus the square root of 2, and I get a decimal approximately 4 4/10. And I'm only going to go to the nearest 10, again, because I'm trying to graph it. I'm not going to be able to get it on very well. Located, excuse me. So x is going to be about 4 4/10. What I'm trying to say, I'm having a difficult time saying it, is that I'm going to round to the nearest tenth because I'm not going to be able to graph 4.414213562, the answer the calculator told me, the approximation, any more accurately. 4 4/10 is as accurate as I'm going to be able to get with the tools I'm using. Now, I also have to do 3 minus the square root of 2, right? 3 minus the square root of 2. And I'm not bringing up my calculator on the screen, but you should know how to do that on your own calculator. And I got about 1 6/10. It was 1 58/100, and again, I went to the nearest 10. So we're going to call it 1 6/10. All right. Now, those are roots or solutions, which means they're on the x-axis. And so I'm going to graph 4 4 4/10 is going to be approximately there. And then 1 6/10 is It's going to be just a smidgen over halfway. I know those points are going to be on the quadratic, on the parabola that the quadratic is going to create. Okay, now let me go find my vertex. To find the vertex, I'll do that in a different color. To find the vertex, I'm going to use part of the quadratic formula. I'm going to use x equals negative b over 2a, right? So x is going to equal 6 over 2 times 1, or 2. X is going to equal 3. Okay, now, I just found something, didn't I? Yeah, I found the x-coordinate of the vertex, but didn't I also find the equation of the axis of symmetry? X equals 3. Now, just a little fun note here. Parabolas have perfect symmetry, right? Our bodies are pretty much symmetrical, but it's not perfect symmetry. You know, you got a freckle on your left shoulder that you don't have on your right shoulder. You know, you've got a scar on one side. Your one ear is slightly higher or lower than the other ear. Okay? But parabolas have perfect symmetry. Now, we've got these answers, 4 4/10 and 1 6/10. If I added them together and divided by 2, in other words, if I found the mean or took the average of the two, what would I get? Well, let's see. 4 4/10 plus 1 6/10 would be 6. Divided by 2 would be 3. That's not a coincidence. That's not a coincidence. That x equals 3 is the location of the axis of symmetry. Okay, so I know the x-coordinate of the vertex. Now I've got to go find the y-coordinate of the vertex, and that's where I will have to plug it in. And I don't remember my original equation. Let's see, what was it? Okay, x squared minus 6x plus 7. All right, so I'm going to go y equals x squared minus 6x plus 7. And I'm going to substitute 3 in for x. And this is going to give me the y-coordinate of the vertex. Six times 3 plus 7. And so now I'm going to get 9 minus 18. And remember, I told you this middle one ends up being twice as big as the first one often. Plus 7. All right, how many positives do I have? 16. How many negatives? 18. The answer must be negative 2. So the vertex is going to be located at 3, negative 2. Now, I can draw my parabola if I want to. What did I say? 3, negative 2. So it's going to be right there. But if I get 2 more points, I can make it a little bit more accurate. So let's see here. I've got my input-output table. And let me see what I can fill in so far. I know, first of all, the vertex is at 3, negative 2. And remember, when you're using these tables, sometimes some of you get confused about where the vertex is. So I put it in the middle, and I'm going to highlight it because it's special. It's the vertex. It's the only point on the parabola that doesn't have any symmetry. All right, so I did that. Now, the quadratic formula told me that 4 4/10 was a solution or a root, and 1 6/10 was a solution or a root. Can I still put 0 in? You know how I like to put 0 in? Yeah, I can do that. If I put 0 in, won't I get 7 out, right? Because I'll get x squared minus 0, x squared, which would be 0, minus 6 times 0, which is 0. So 0 minus 0 plus 7, yeah. Now, how far is 0 from the vertex? Well, it's 3 whole units. So I'm going to go 3 whole units the other way and put 6 in, which means the y-coordinate will be 7 due to symmetry. So let me come up here and go to 0, 7, and then 6, 7, and I can draw my parabola. Now, I have a hard time drawing parabolas with the airliner tool, so I'll do the best I can. It doesn't look too shabby, and I think I'll try to cheat here. I'm going to clone that. And I'm going to flip root for reflect him. Where is it at? Clone, copy, delete, flip, left, right. There we go. And that's pretty close. That's about what it should look like. It should definitely be rounded here, not coming to a point. Okay, so there I went through 9.6 and 9.3, everything involved, all right? I'm going to do one more example, and then we'll call it quits for this video. And I'll take the same exact approach that I took that one. I'm going to start with the 9.6 stuff. So I'm going to get ABC, ABC. Easy as -4, 8, 1. Okay, and I believe I went right to the quadratic formula. So I'm going to go x equals the negative of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so this will give me the places where the parabola will cross the x-axis. Now, remember this part under here, the b squared minus 4ac part. That's called the discriminant. And if the discriminant is positive, you will get 2 solutions or 2 roots. If the discriminant is 0, you'll get 1. And if b squared minus 4ac is negative or less than 0, you will get 0 solutions. All right, it's kind of early in the day, but the rain is making me sleepy. So I'm going to get -8 plus or minus the square root of 64 plus 16. Okay, and that's going to be over -8. So x equals -8 plus or minus the square root of 80. Oh darn, I almost had a perfect square. That would have been made easy. Ask really quick, please. My daughter's here. She wants to ask a question.
Oh, the things that Mommy made, I didn't need all of them.
Okay, bring them up.
I did.
Okay, thank you. How about you get some homework done? Okay, so I'm going to break down the square root of 80. So let's see here, the square root of 80. I need a perfect square that goes into 80. The bigger the better. I'm thinking 16. I think 16 goes in. 5 times, right? Yeah. So I could rewrite 80 as the square root of 16 times the square root of 5, which is going to equal 4 rad 5. Okay, so I have -8 plus or minus 4 rad 5 over -8. Now, I can simplify this a little bit, but not as much as I would like, because in the last one, the denominator was going into both evenly. Here they'll simplify. I got to make sure I don't oversimplify. So this would allow me to divide by 4, right? I can divide this by 4, divide that by 4, and I can divide that by 4. I'm not going to use 8 because 8 won't go into that evenly. So x is going to equal, if I divide this by 4, I'm going to get -2 plus or minus square root of 5, and the whole thing is being divided by 2. Coincidentally, if you do it on the calculator, if you do the red part or the black part there, you'll get the same decimal approximation, okay? So -2 plus the square root of 5. I have that decimal, and then I'm going to divide it by 2, and I get about 1/10. So x is going to be approximately 1/10. And now I have to do -2 minus the square root of 5 and divide that by 2, and that's going to be -2 and 1/10. And I'll bet you my vertex is going to be at -1. I got a feeling it's going to be at -1. I really do. But let's go ahead and find it here. Let me plot those. So let's see here. 1/10 is going to be like real tight right there. -2 and 1/10 is going to be really tight right there. Okay, so let me go looking for the vertex. I need negative b over 2a. So x is going to equal the negative b over 2 times a. Oh, that's not right. I feel like I'm making a mistake here. Let me see, what was a? A was negative b over 2a. Yeah, that's right. I'm doing that right. I'm bothered by something, ladies and gentlemen. I can't see. I feel like I've made a mistake because I'm getting a vertex of 1. I've got a sign error somewhere, right? I've got a sign error somewhere because this is going to come out to be positive 1. And this cannot be right because I have my axis of symmetry here at x equals 1. But it needs to be between my two roots or my two solutions. So I definitely have a small error. So here's how we're going to fix this. First thing I'm going to do is I'm going to check my axis of symmetry, make sure it's right. If I'm convinced that's right, because that's a pretty simple procedure, then I will go ahead and recheck my, my roots because perhaps I have a mistake along the way. Oh, and I think I see it. Yep, I do. Do you see it? It's right here. It's a sign error. There it is. That's a negative 2. Yeah, because that 8 was negative right there. So that's going to change my signs, which is going to cause the 1/10 to be negative and the 2 1/10 to be positive. And that is going to move these roots. So I feel much better about that because now when I average those two, I get x equals 1. Yeah, I was just checking my work. So we're going to have negative 1/10, which is going to be very close to the origin, and positive 2 1/10, which is going to be about there. All right. I know the x-coordinate of the vertex is 1, and so I'm going to have y equals negative 4 times 1 squared plus 8 times 1 plus, and I don't remember what it is, plus 1. Okay, so when I simplify this, I'm going to get negative 4, because 1 squared is 1 times negative 4 is negative 4, plus 8 plus 1. So y is going to equal 5, I believe, yes? Okay, 9, positive 9, negative 4. So my vertex is at 1, 5. So it's right here. Hey, did you notice? The parabola is going to open downward. Of course, you probably knew that because A was negative. That causes the parabola to open downward. Now, my output table, I don't think I'm going to put the other 2 points in because if I plug 0 in here, well, all right, I can plug 0 in. If I plug 0 into the equation, I'm going to get 1. That's 1 unit away, so I'm going to plug 2 in. I guarantee I'm also going to get 1 because of symmetry. And let me draw my parabola. Uh-oh, I'm running off my airliner there. Here, it's kind of hard to draw with the airliner, but that's not too shabby. All right, so there we did 2 sample problems. Remember your discriminant, b squared minus 4ac. Okay, if it's greater than 0, you're going to get 2 roots or 2 solutions, right? When it's equal to 0, you're going to get 1 root or 1 solution. And when it's less than 0, you're going to get no or 0 roots, 0 solutions. Incidentally, if b squared minus 4ac is a perfect square, you could have factored the expression. All right, remember that a is going to turn it negative, and don't forget your song. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Mr. Lawrence signing off. Have a good day, everybody.